In this episode, we begin by focusing on a truth that makes payment security feel more real and less theoretical. Most damaging card data incidents are not caused by a single dramatic event, but by stored data sitting in the wrong place, protected in the wrong way, for longer than anyone realized. Beginners often assume the main danger is data being stolen while it moves across the network, yet the quieter risk is data at rest, meaning data stored on systems, in files, in databases, in logs, and in backups. Stored account data becomes attractive because it can be collected in bulk, and bulk is what turns a small security mistake into a major breach. In the payment card industry, PCI, world, protecting stored account data is central because the cardholder data environment, CDE, is defined partly by where that data lives, and because the rules for storing, limiting, and securing it are built to reduce both the chance of exposure and the impact if something goes wrong. When you learn how to protect stored account data properly, you learn how to reduce risk by design, not by luck. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.Me in the Bare Metal Study Guide series. A strong starting point is understanding what stored account data includes, because people often confuse different categories, and that confusion leads to either overprotecting irrelevant data or underprotecting the most sensitive pieces. The primary account number, PAN, is the foundation of cardholder data, and if it is stored, it must be protected with strong controls because it can identify the account. Other elements like the cardholder name and expiration date become more sensitive when combined with the PAN, which is why PCI treats the combination seriously. There is also a category called sensitive authentication data, which includes things like the data encoded on the magnetic stripe, the chip data, and the card verification code. And this category is especially restricted because it can enable fraud even more directly. Beginners sometimes think these elements are all just card info, but PCI makes clear distinctions because the risks differ and the rules differ. A key habit is being precise. Know which data elements are present, where they are stored, and whether there is a valid reason for them to exist there. Precision is what lets you protect correctly and also shrink scope when data does not need to be stored. The first and most powerful protection for stored data is minimizing it, because the safest stored data is the data you never store at all. Minimization means you actively decide what you truly need to keep for business reasons, and you remove or avoid storing everything else. For many payment environments, storing full card numbers is unnecessary for day-to-day operations, and reducing storage can dramatically lower risk and compliance burden. Beginners sometimes think minimizing data is a sacrifice, as if you are giving up useful information, but in practice it can simplify operations by reducing what must be protected, what must be monitored, and what must be audited. Minimization also reduces the chance that sensitive data spreads into logs, exports, and user-created files, because the less it exists, the fewer opportunities there are for accidental copying. In a PCI mindset, minimization is not a nice-to-have. It is a core strategy for reducing harm. When you treat minimization as a design goal, you are already protecting stored account data before any encryption or access control decisions even begin. Tokenization and truncation are common ways to support minimization, and understanding their role helps you protect stored data without breaking business needs. Tokenization replaces the full card number with a token that can be stored and used for business functions without revealing the original value. Truncation permanently removes part of the card number, often leaving only the last few digits so that records can be matched and referenced without storing the full number. Both techniques reduce exposure, but they only reduce risk if they are used correctly and early enough in the data flow so that full values do not end up stored elsewhere. Beginners sometimes assume that if a system displays only partial digits, it must be storing only partial digits, but display and storage are different, and the risk is in what is truly stored. Wise use of tokenization and truncation requires you to verify where the full primary account number, PAN, exists, where it is eliminated, and where only safe substitutes remain. When these techniques are applied thoughtfully, They shrink the amount of stored sensitive data and make the remaining storage easier to protect. When storage of cardholder data is necessary, encryption is a major control, but beginners should think of encryption as part of a system rather than as a magic feature. Encryption protects confidentiality by making data unreadable without the right keys. So even if an attacker steals the stored files or database contents, the data should remain protected. However, encryption only provides real protection if key management is strong, because weak key management can turn encryption into a decorative label rather than a barrier. If keys are stored alongside the encrypted data, if too many people can access them, or if the same keys are used in unsafe ways, the practical protection can collapse. For beginners, the important idea is that protecting stored account data means protecting the data and the ability to decrypt it, and those two must be separated and controlled. You do not need to be a cryptography expert to understand this. You need to understand that encryption is strongest when access to keys is tightly limited, monitored, and governed. When you can explain encryption together with key control, you show mature understanding of why encryption works. Access control is the next crucial layer, because data at rest is exposed not only when attackers steal files, but also when authorized access is too broad. The principle of least privilege applies here, meaning only the people and systems that truly need access to stored account data should have it, and everyone else should be blocked. Beginners sometimes assume that if a person is an employee, they are safe to grant access to sensitive data, but payment security treats access as a specific need, not a general trust status. Access control includes not only who can view data, but who can export it, who can copy it, and who can administer the systems that store it. Administrative access can be especially risky because administrators can often bypass normal application controls, which means the protection must include limiting and monitoring administrative pathways. Strong access control reduces accidental exposure as well, because fewer people have the opportunity to mishandle data. When access is constrained and reviewed, stored account data is less likely to leak through routine workflows. Another often overlooked cause of stored data exposure is the way applications and business processes create secondary copies of data. Reports generated for finance, exports used for reconciliation, attachments added to support tickets, and screenshots taken during troubleshooting can all become stored account data exposures if they include the primary account number, PAN, or other sensitive elements. These copies are dangerous because they often live outside the controlled database, in file shares, email inboxes, collaboration tools, or personal devices where protections are weaker. Beginners sometimes focus on the main database and forget these shadow storage locations, but attackers and accidents often exploit shadow storage because it is less monitored. Protecting stored data, therefore, includes controlling how data is displayed, how it is logged, and how it is shared, because those pathways create stored artifacts. It also includes educating teams and designing systems to avoid exposing full values unnecessarily, so that people are not tempted to copy what they should not have. When you treat business workflows as part of data at rest risk, your protection strategy becomes more complete. Logs are a special category of stored data that can become a severe exposure if they capture sensitive fields, especially during errors and debugging. Many systems log input data when something goes wrong, and if that input includes card data, logs can become a hidden repository of sensitive information. Logs are also typically centralized and retained, which means one accidental leak can spread widely and persist for a long time. Beginners often assume logs are harmless technical records, but in payment environments they must be treated as potential sensitive storage and handled carefully. Protecting stored account data includes ensuring logs do not record full card numbers and that any logs that do exist are protected with strong access control and integrity protections. It also includes monitoring for data leakage patterns, because repeated leakage into logs can indicate a systemic issue in application design or error handling. When you can explain why logs are both necessary and risky, you show that you understand real-world data exposure pathways rather than only the obvious ones. Backups and archives are another major risk area because they preserve historical versions of stored data and often exist in multiple locations. If a system stores account data, backups likely store it too, and backups can be copied, moved, and retained for long periods. Beginners sometimes assume that if the main system is secure, the backups are automatically secure, but backups often have different access controls and may be handled by different teams or service providers. A breach involving backups can be particularly damaging because backups can contain large amounts of data and may include data that was supposed to have been deleted from the live system. Protecting stored account data, therefore, includes ensuring backups are protected with strong controls, including encryption and restricted access, and ensuring retention policies are aligned with minimization goals. It also includes understanding how restoration works, because during an emergency, teams may restore data quickly and unintentionally reintroduce sensitive information into places that were previously cleaned. When backup security is treated as part of data at rest protection, the strategy becomes durable rather than superficial. Integrity and tamper resistance matter as well, because stored account data must not only remain confidential, but also remain accurate and trustworthy. If attackers can alter transaction records or stored account references, they can cause financial harm and make investigations more difficult. Controls that protect integrity include limiting who can modify stored records, maintaining reliable logs of changes, and ensuring that the systems storing data are themselves hardened and monitored. Beginners sometimes think of data protection as only confidentiality, but integrity is part of protecting customers and businesses because altered records can lead to fraud and disputes. Integrity also affects compliance evidence, because if you cannot trust stored data and logs, you cannot prove what happened during an incident. Protecting stored account data, therefore, includes maintaining a chain of confidence that the data has not been silently altered. When you connect confidentiality and integrity together, you build a more complete understanding of why PCI emphasizes controlled storage environments. Service providers add complexity to data at rest protection because stored data may exist in vendor-managed systems or be influenced by vendor-managed platforms. If a payment processor, hosting provider, or managed service stores account data or handles backups and logs, you must understand where the data resides and what protections the provider applies. Shared responsibility means you cannot assume that a provider's general security posture covers your specific data flow. You need clarity about what data they store, how long they retain it, and how access is controlled. Beginners sometimes assume that outsourcing automatically makes storage safer, but outsourcing can also expand the number of parties and systems involved, which can increase risk if governance is weak. Protecting stored account data in a shared environment means aligning provider controls with your requirements, verifying their evidence, and ensuring boundaries are clear. It also means understanding how data is transferred between you and the provider, because storage can occur on both sides, especially in logs and reports. When you treat provider-managed storage as part of your data protection story, your approach becomes realistic. Finally, protecting stored account data requires ongoing checking, because data storage patterns can change as applications evolve, teams change workflows, and systems are updated. A new logging setting, a new report, or a new integration can accidentally create a fresh place where full card numbers are stored. Data minimization can erode over time if old exports are never cleaned up or if backup retention grows without oversight. A mature approach treats stored data protection as a living practice, where you periodically confirm what data exists, where it exists, and whether controls still match the risk. This is not about constant paranoia. It is about preventing slow drift into a more exposed state. When you keep the habit of verifying storage locations and protections, you reduce surprises during assessments and reduce the chance of silent accumulation becoming a major breach. Protecting data at rest is therefore both design and maintenance, not just a one-time set of rules. By the end of this lesson, the key takeaway is that protecting stored account data is about controlling what exists, where it exists, who can access it, and how it stays protected over time. You start with minimization, using techniques like tokenization and truncation to reduce how much sensitive data is stored at all. Then you apply strong encryption and key control where storage is necessary. You restrict access tightly, account for shadow storage in reports and files, and treat logs and backups as serious storage locations that can amplify exposure. You also protect integrity so records remain trustworthy, and you manage shared responsibility with providers so vendor-managed storage does not become a blind spot. When these pieces fit together, the CDE becomes smaller, clearer, and harder to compromise, And you can explain not only what you did, but why it reduces real-world risk, which is exactly the kind of disciplined thinking PCI expects.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.